Good morning students, welcome to my YouTube channel The Tactical Online Academy. This video is for the students who are preparing for MBBS entrance examination or engineering entrance examination. Today I am going to teach you components of vectors. So let's start to study. Let's start to study components of vectors. First of all, a vector can have infinite components. A vector can have infinite components in all possible directions. The vectors can have infinite components, but in the rectangular plane, like in the rectangular plane, it can have two components. A vector has two components in a rectangular plane. And those two components are horizontal component and vertical component. Like one component is horizontal component, and horizontal component is along the x-axis, so it can have one horizontal component, and horizontal component is along the x-axis, and it can have the vertical component also, and vertical component is along the y-axis, so it can have two components in rectangular plane, and that is horizontal component and vertical component. Horizontal component is along the x-axis and vertical component is along the y-axis. I am going to clarify you with figures here. Suppose here we have a vector like this. Let's say it is O point, and which is origin, and here is P point. And suppose here is P vector. Here is P vector along this direction. Then you know this is the x-axis. So along the x-axis it can have one component, and the component along x-axis, this one component along x-axis, let's say this is point A, and component along x-axis here, this one OA is the horizontal component, and here we can draw y-axis and component along y-axis, like here. Suppose this is the point B, so OA is x component and OB is y component. So OA is the horizontal component of P vector, and OB is vertical component of this P vector. So here it can be written as OA is P cos theta, which is horizontal component, and OB is P sin theta. So P sin theta is the vertical component. So a vector can have two components in rectangular plane, and one component is horizontal component, and which is along x-axis, and another component is vertical component, and vertical component of the vector is along the y-axis, and horizontal component of P vector is P cos theta, and vertical component of P vector is P sin theta. So this is two components in rectangular plane. So a vector can have only two components in the rectangular plane. And similarly in three-dimensional space, like in 3D space, a vector can have three components. There are three components. There are three components in 3D space, three-dimensional space, and those three components are along x-axis, along x-axis, uh, along x-axis, and along y-axis and along z-axis. So there are three components of vector in 3D space, and that is along x-axis, y-axis and z-axis. For example, suppose we have a r vector, then the r vector in 3D space, 3D space. Then R vector in 3D space can have three components, and one component is along x-axis, which can be written Rx, and along y-axis it has another component and it is written Ry, and it has another component along z-axis and it is written as Rz. So there are two components of a vector in rectangular space, but in the 3D space a vector has three components. So now let's focus on vector vector in rectangular plane. Vector in rectangular plane. I have already said you, in rectangular plane a vector can have two components. Suppose we have a r vector, then it can have two components, horizontal component and vertical component. And in horizontal component, it is r cos theta is one component. It is the horizontal component, r cos theta, horizontal component. Then r sin theta, it is the vertical component. Vertical component. So horizontal component is r cos theta and vertical component is r sin theta. And horizontal component is written as Rx because it is in the x-axis, and Rx equals to r cos theta, it can be written, which is the horizontal component. And it is the horizontal component. Rx equals to r cos theta, it is the horizontal component. Horizontal component. And vertical component is Ry, and it is r sin theta. So it is the vertical component. Vertical component. This is the formula you have to know. If we have r vector in the rectangular plane, then horizontal component is r cos theta, and which is denoted by rx, and vertical component is r sin theta, which is denoted by ry. Then let's see the magnitude of vector. Now if we have vector r vector and it has component rx in horizontal component, and it has ry in vertical component, then magnitude of r vector is given by, see, right, magnitude of r vector is given by r vector equals to root under rx square plus ry square. So it is the formula of magnitude of r vector. Magnitude of r vector equals to rx square plus ry square root under. So this is the formula of the magnitude of r vector, and it is written as modulus of r vector. So modulus of r vector equals to rx square plus ry square root under, and rx is the horizontal component and ry is the vertical component. Now let's see the direction. Suppose the r vector makes angle alpha with the x-axis, that means with horizontal axis, horizontal plane, then alpha equals to tan inverse ry upon rx, that means vertical component upon horizontal component. So this is the direction of r vector. Direction is ry vector, ry upon rx. So this is the direction of the r vector. And suppose in a rectangular plane we have a vector and r vector has equal component. Suppose we have two equal component. If r vector has equal components, r vector has two equal components in x-axis and y-axis. That means it has two horizontal and vertical component and they are equal. R vector has two equal components means rx equals to ry. If rx equals to ry, then the vector makes certain angle with both component. And how much angle is made with both components? Let's see. Suppose it has two equal components. Then you have to know r vector exactly makes, in this condition, r vector exactly makes angle cos inverse 1 by root 2 or 45-degree angle. See here, what is the reason behind this? If r vector makes equal component in horizontal and vertical direction, or if r vector makes equal angle, equal component in x-axis and y-axis, then r vector makes exactly 45-degree angle with both component. R vector makes 45-degree angle with horizontal component and r vector makes exactly 45-degree angle with vertical component. What is the reason behind this? Let's see detailedly. I have already said you the magnitude of r vector. You know it is equals to root under rx square plus ry square. It is the formula of magnitude of r vector. And now suppose magnitude of r vector is simply r. Then you know rx equals to r cos theta. So it is the formula of horizontal components. Rx equals to simply r cos theta. Now we can write like this: Rx upon r equals to cos theta. Then theta is the angle made by r vector with horizontal component. Then you know the formula of r. I have just before I have written rx equals to root under rx square plus ry square. So it is equals to cos theta. So this is the formula of r. R equals to root under rx square plus ry square. Now according to the condition, rx equals to ry. So we can write here rx upon root under rx square plus rx square, because rx equals to ry. So rx is upon rx square plus rx square equals to cos theta. So it can be written here. Then it is obtained here cos theta equals to rx upon root under 2rx square. Then you know it is obtained cos theta equals to rx upon rx root 2, and rx cancel. Then here we will obtain cos theta equals to 1 by root 2. That is the reason the angle made by the r vector with both component is theta equals to cos inverse 1 by root 2, and it is equals to 45-degree. So you have to know if r vector makes equal component, r vector make two equal components in rectangular plane, then it makes 45-degree angle with horizontal component and vertical component both. Now let's see the vector in 3D space. Then you know there are three components rx, ry and rz in three components. Then in this case magnitude of r vector equals to root under rx square plus ry square plus rz square. This is the formula of magnitude of r vector if r vector is in 3D space, three dimensional space. So this much only for today's video. Thank you very much.